Hello, welcome to the course Big Data Analytics. In this, we will see introduction to Hadoop. Coming to the outline, first let us start with Hadoop introduction, then history, then features, then Hadoop master-slave architecture, then Hadoop characteristics, Hadoop versions, finally Hadoop components. Coming to the Hadoop introduction, Apache Hadoop, which is an open source framework that allows us to store and process large data sets in parallel and distributed manner. The Apache Hadoop software library, which is a framework that allows for the distributed processing of large data sets across clusters of computers using some simple programming models. It is designed to scale up from single servers to thousands of machines, where each offering local computation and storage. Rather than rely on hardware to deliver high availability, the library itself is designed to detect and handle failures at the application layer. So, delivering a high available service on top of a cluster of computers, each of which may be prone to failures. If you can see the components of Hadoop majorly, consisting of two important components. First one is HDFS, stands for Hadoop Distributed File System. Another one, MapReduce. Whereas HDFS is a storage in distributed file system manner, whereas MapReduce is for processing, allows parallel and distributed processing. Coming to the history of Hadoop. Hadoop, as we already know, is an open source project. So that is from the Apache Foundation. It is a framework initially written in Java. Hadoop was developed by Doug Cutting in 2005. It was originally developed to support distribution of the Nuts search engine project. Doug, who was working at Yahoo at that time, who is now actually a chief architect at Cloudera, has named this project after his son's toy elephant named Hadoop. That's why the icon of Hadoop is elephant image. If you can see the history from 2002 to 2009, first 2002, Doug Cutting started working on Nudge project. Then 2003 to 4, Google published GFS and MapReduce papers. Then in 2004, Doug Cutting added distributed file system and MapReduce in Nudge project. Then 2005, there is no any improvement. Then coming to 2006, so 2006 development of Hadoop started as a Lucent's sub-project here. Then the New York Times published this one, 2007, converted 4 TB of image archives over 100 EC square instances. Then 2008, here Facebook launched Hive SQL support for Hadoop. Also, Hadoop became top level project. Then Hadoop defeated supercomputers in 2008 is very a good time for the Hadoop. Then in 2009, Doug Cutting joined in Cloudera as a chief architect. This is the history of Hadoop since its inception. Then coming to features of Hadoop. Hadoop is optimized to handle massive quantities of structured, semi-structured, and unstructured data. How? By using some commodity hardware that is relatively inexpensive computers. Hadoop has a shared nothing architecture. Hadoop also replicates its data across multiple computers so that if one goes down, the data can still be processed from another machine that stores its replica. This is one of the important feature of Hadoop. Hadoop is for high throughput rather than low latency. It is a batch operation handling massive quantities of data. Therefore, the response time is not immediate. It also complements the OLTP, which is online transaction processing, and OLAM, that is online analytical mining. However, it is not a replacement for a relational database management system, that is RDBMS. It is not good when work cannot be parallelized or when there are dependencies within the data. This is the limitation. And also, it is not good for processing small files. It works best with huge data files and data sets. That means whenever the data is large, then only it works well. For smaller files, it is not good enough. Then coming to Hadoop master-slave architecture. Let us begin with one example, one scenario. Let us see. Here, a project manager managing a team of 4 employees. He assigns project to each of them and tracks the progress. This is the scenario. So visually here you can see the center project manager is located. Then the 4 employees. Let us take for illustration only this image. So let us say John, James, Alice, Bob. So these 4 team has assigned one project by the project manager. Then the project manager wants to track the progress of all the 4 team members about the project work progress. Let us see here in this scenario. So here first we are having metadata about all the 4 team members. Let us name it as A, B, C, D with the respective names. So that the project A is allotted to John, then project B is allotted to James, then project C is allotted to Bob, and the project D allotted to Alice. Then project manager so wants to check the progress of all the 4 team members. So first, the project manager may interact with any of the 4 members, then wait for the progress. So in this case here, you can see first the project manager approaches James to know the progress. Next time, here you can see either A or D, so wants to approach. But here you can see project C, uh, progress is not updated here. Here that means here some doubt arises. What is the problem occurred here? So not aware. So what is going on? What happened? Then similarly here like that rotating interacting with all the members related to that project to check the progress. So finally, here you can see like that the project manager will interact with all the 4 members of the team to verify the progress of the project work. Here you can see this, you can make it as that a project manager now becomes master node because all are under control of a project manager. Then all the individual 4 members called as slave nodes. So then the interaction among master node, slave node. That's why it is called as master slave architecture. See if you can represent the final architecture like this. Here you are having bottom master node, then all the 4 slave nodes are connected. This is like client server communication, client server technology. Similar to that, Hadoop also follows the same master slave architecture. Here, master is the project manager, slaves are the team members. In computer terminology, so master node and slave nodes. So this is the simple master slave architecture. Like that, here, thousands of slave nodes may be added or connected to one master node. So now finally coming to the nodes, what are the important nodes available in Hadoop master slave architecture? So we are having, as we have mentioned in the previous diagram, we are having master node, slave node. Then between master node and slave node, we are having some components, that is Hadoop earn at another resource negotiator, then Hadoop HDFS. So here between master node to slave node, here Hadoop earn consisting of resource manager, node manager. Similarly, between master node and slave node, through Hadoop distributed file system, which consisting of name node, data node. So finally here we are having master node, slave node, then name node, data node, then resource manager, node manager. These are all the major components of Hadoop. If you can see the expansion of this architecture with four slave nodes becomes 100 slave nodes, the architecture looks like this. So here user works with this master slave architecture, one master, so 100 slaves like that. Here you can see each slave which assigned to a sub work. Here you can see all the sub work or subtasks. So parallelly, the advantage of Hadoop, which follows distributed environment for storing data, large data into different clusters in different locations. Then the processing, parallel processing of the tasks or job that can be done using map reduce paradigm. Parallelly, suppose here 100 slaves, all 100 slaves, that particular subtask performed at a time parallelly. So that is the main motto of Hadoop. Then coming to Hadoop characteristics. So Hadoop majorly having the following characteristics. Let us see here. So which is a open source, which allows distributed processing, having fault tolerance, then high reliable, high available, then high scalable. It is economic and it is easy to use. These are the major characteristics of Hadoop. Let us see with a little bit more about all this. So as we already mentioned, Hadoop is open source. Here, source code is freely available. It can be redistributed. It can be modified. So here open source means it is a free, interoperable, no vendor lock, it is community based, affordable, transparent. These are the advantages of open source. That's why Hadoop is also a open source. Then distributed processing. Here data is processed distributedly on cluster. Multiple nodes in the cluster process data independently. Here you can see, so here we are having centralized processing, then distributed processing. Here middle we are having a master, let us assume, then surrounding all we will call it as slave. So central processing as well as distributed processing. Then fault tolerance. So what is meaning of fault tolerance in case of failure? Failure of nodes are recovered automatically. Framework takes care of failure of hardware as well tasks. Suppose here if any one node or one slave node failed due to hardware failure or system crash because of already having its backup, due to that backup, so again the processing resumes as usual. That's why failure of nodes are recovered automatically. Then reliability. That means data is reliably stored on the cluster of machines even any machine fails. Failure of nodes doesn't cause data loss. For example, in this visual representation, two nodes are crashed, even no problem, even two or any number of nodes are failed, it resumes the normal processing of the task. There is no data loss here. That is the advantage of Hadoop. That is the reliability, more reliable. Then high availability. Even if any node is failed because of the backups, always data is available. Data is highly available and accessible despite hardware failures. There will be no downtime for end user application due to the data. That's why high availability is very important in Hadoop. Then scalability, you can expand so with as many number of slaves whenever data size is increased. That's why vertical scalability is possible. So here new hardware can be added to both nodes. Whereas horizontal scalability, new nodes can be added on the fly whenever required. That's why scalability is also possible in Hadoop is highly scalable. Then economic. Here we already mentioned Hadoop is open source framework. That's why no need to purchase costly license and also no need to purchase costly hardware. Open source plus with existing commodity hardware. Because of these two advantages, so it is more economical. Then it is easy to use. Distributed computing challenges are handled by this framework. Client just need to concentrate on business logic instead of the commodity of the hardwares. That's why it is easy to use. Then data locality. So here move computation to data instead of data to computation. Here data is processed on the nodes where it is stored. So here you can see the first scenario, we have storage servers. Different servers are there. Data is stored on different servers. Then we are having application servers then to write the programs or to process the data. So, but in Hadoop, it is not required actually. Why? Because whatever the mechanism or algorithm or procedure you are applying, all the servers. So individually applies that algorithm to that data available in that server. Here you can see individual servers algorithm data. So parallelly in all servers, so algorithm is applied on the available data. That's why data locality is one of the important feature in Hadoop. Then coming to various versions of Hadoop. Initially, Hadoop 1.0 released in December 2011 by Apache Software Foundation. Released the first version, Apache Hadoop version 1.0. It has two parts, data storage framework, that is HDFS, Hadoop Distributed File System, and a data processing framework, that is Paradiddm, that is MapReduce Paradiddm. Then the second version, Hadoop 2.0, released in August 2013. So its version is called as Apache Hadoop version 2.0.6. This version is available. Additionally, it includes a new separate resource and management framework called ARN at another resource negotiator. So that ARN was introduced in second version of Hadoop. First version we are having only HDFS and MapReduce. Second version we are having additional component, that is ARN. Then Hadoop 3.0 released in December 2017. So its version, Apache Hadoop version 3.0, so was available. At present now 3.3.6, the subversions are there. Fourth version not yet released as on date. So 3.0 with variants version is running till date. Then coming to various components of Hadoop. So we already seen majorly Hadoop consisting of these three components. First one is HDFS, then AR, then MapReduce. HDFS is a distributed file system. Then AR is the default operating system of Hadoop. Then MapReduce is the distributed processing paradigm, like programming approach. Let us see these three components with little bit. Here, coming to the HDFS, Hadoop Distributed File System. So Hadoop Distributed File System is a dedicated file system to store big data with a cluster of commodity hardware or cheaper hardware with the streaming access pattern. It enables data to be stored at multiple nodes in the cluster, also ensures data security and fault tolerance. More we will see in upcoming lectures in detail about HDFS. Then coming to the map reduce. Here data once stored in the HDFS also needs to be processed upon further. Now suppose a query is sent to process a data set in the HDFS. Now Hadoop identifies where this data is stored. This is called mapping. Locating the data, that is called as mapping. Then now the query is broken into multiple parts and the results of all these multiple parts are combined. Then the overall result is sent back to the user. The overall result combining the individual results is called as reduced process. Finally, while HDFS use it to store the data, whereas MapReduce use it to process the data. So that is the MapReduce. Then ARN is the another component which stands for Yet Another Resource Negotiator. It is a dedicated operating system for Hadoop, which manages the resources of the cluster and also functions as a framework for job scheduling in Hadoop. So there are various types of scheduling that we already know in operating systems. We are having first come, first serve, FCFS, then fair share scheduler, then capacity scheduler, etc. These are all some of the scheduling types. So the first come, first serve scheduling is set by default in an component. Yeah, these are all the components of Hadoop. So in upcoming lectures, we will discuss more about HDFS and MapReduce. Till then, stay tuned for latest updates.